Sir, present, sir.
Patchmoda. Okay. Janvi. Janvi.
Present, sir.
Right.
Present, sir.
Okay. Mahadev. Mahadev. Mohammed. Mohammed. Kirti.
Present, sir.
Right. Pikesh. Pikesh. Prajwal Gowda.
Present, sir.
Okay. Ramesh. Ramesh. Ratan. Ratan. Rohan. Rohan. Rutik Chopde.
Present, sir.
Right. Rutvik Gune.
Present, sir.
Okay. Sadashiv. Sadashiv. Sagar. Sagar.
Sir.
Okay. Sai Prakash.
Present, sir.
Right. Samir Ahmad. Samir Ahmad. Sania.
Present, sir.
Right. Sanjay. Sanjay. Sankalp.
Present, sir.
Sankalp. Okay. Sanket.
Present, sir.
Right.
Yes, sir.
Okay. Shiraj.
Present, sir.
Shiraj. Right. Shivnanda. Shivnanda. Shraddha. Shraddha. Shubham. Sumit. Sumit. Suraya Banu. Suraya Banu. Okay.
Present, sir.
Tejas. Tejas. Vivek. Vivek. Yamunappa. Yamunappa. गांवकर रजत रामचंद्र. गांवकर रजत रामचंद्र. मंजुनाथ. प्रथमेश. प्रथमेश.
Present, sir.
Okay.
Present, sir.
Right. Joslino. Joslino. Okay. Anybody else?
Sir, excuse me, sir.
Shubham. Yes, please.
Sir. Sir, roll
Yes,
number
yes.
5
Tell
present,
me.
sir. Roll number 5.
Roll number 5.
Sir, roll
Okay.
number 5. Yeah.
Okay. Okay.
Remember.
I will mark yours. Okay. You are present, right? Anybody else? Anybody else joined?
Sir,
Okay.
28.
Mahadev Wadeyer. 20.
Sir, 28. Shubham.
Shubham. I have marked. Anybody else?
Okay.
Mahadev Wadeyer. I have marked. Okay.
Alright, yes. Okay, do you know what it says there? Yes, it's a complex form, which is nothing e raised to j theta. Okay, what do you mean by e raised to j theta? It's when you propose one unit e raised to j theta. Meaning of this one was, it has a one radius, okay, with a negative one, has a one radius, and it is rotating in the form of we all know, with the real as well as the complex imaginary part, it is going to be rotating. Okay, so with respect to j theta. Okay, j theta means j. So it is moving like this. That is the meaning of the case. Okay, even like this transformation. Similarly, we also have that meaning of this is it not only as the as also imaginary part. Okay, and it is moving in rotating circular direction. Okay, let's see whether there are. I'm not going to specify what also we are going to say. Okay, this is.
Are you able to see the screen here? Screen is visible?
Yes, sir.
Okay. In the last class, we were discussing about the emitter follower configuration. Emitter follower configuration is a one in which the output is at the emitter and the input is applied to the base. Output voltage at emitter follows the input voltage at the base. This is called as emitter follower configuration, and it is also the common collector configuration because the collector is common to both the input and the output circuits. Hence it is also called as common collector configuration. Common collector, this collector is common between the input and output sections, and hence it is also called as common collector configuration. Next, we discussed that the gain of the circuit is approximately unity, it is 1. For emitter follower, the voltage gain is 1, and hence the output will follow the input. Output is equal to input, or the output follows the input. Here, R naught is not considered for simplicity. Output resistance is less, and it can be neglected. It is not considered for simplicity. This is how we are drawing the RE model. We have the base resistance RB, beta RE. I told how this beta RE is obtained by replacing the diode circuit. So diode is nothing but it is replaced by RE resistance, and we know that I is equal to 26 millivolt by RE, or RE is equal to 26 millivolt by IE. IE is beta times IB, beta plus 1 into IB, that is beta into IB, because beta is larger than 1. Therefore, we get IE is equal to RE divided by IE is equal to 26 millivolt by beta RE. Therefore, the resistance is shown as beta RE, and the current is IB. Current is IB. IB and IC is equal to beta times IB. Both IB and IC are flowing into the transistor, and the IE is flowing away from the transistor. Okay, and I naught is into the transistor. According to our convention, I naught is into the transistor. Note that here I and I naught are opposite in direction. I and I naught both are opposite in direction. Let us find the value of input impedance Zi. If we apply KVL to the input circuit, if we apply KVL to this input circuit, so what we have here, Vi is equal to, Vi is given by, what is the voltage at the input? Vi given by, Vi is nothing but from this base terminal to ground. Voltage from base terminal to ground, that is our input voltage. It is IB into beta RE, IB into beta RE plus V naught. What is V naught? IE into RE. Vi is equal to IB into beta RE. Apply KVL. IB into beta RE plus I naught IE into RE. IE into RE. That is what it is written here. Vi is equal to IB into beta RE plus IE RE according to the Kirchhoff's voltage law. But we know that IE is equal to 1 plus beta into IB. IE is 1 plus beta into IB, or this, if we replace this IE by 1 plus beta into IB, then we have Vi is equal to IB into beta RE plus IE is 1 plus beta into IB. So write it, IE is 1 plus beta IB into RE, into capital RE. Therefore, the equation is Vi is equal to IB into beta RE as it is. IE is replaced by 1 plus beta IB into RE. ZB is given by, what is ZB? The impedance at the base terminal. If you look into this circuit, the impedance at this terminal, base terminal is nothing but the ZB, the impedance at the base terminal. So this impedance at the base terminal is the voltage Vi, input voltage Vi, input voltage at the base terminal is Vi, and the current, what is the current? It is IB. IB is the input current to the base terminal. Input voltage is Vi, and the current to the into the base terminal is IB. Okay, so Vi by IB gives ZB. What is what is impedance ZB? That is impedance at the base terminal. It is voltage at the base terminal, that is Vi, divided by the current into the base terminal, that is IB. Vi by IB. Vi by IB. That is ZB is equal to Vi divided by IB. We have already derived the formula for Vi. Substitute that. Vi is in the above equation, that is IB beta RE. Take IB common, it will be IB multiplied by beta RE plus 1 plus beta into capital RE. Take IB common here, it will be IB multiplied by beta RE plus 1 plus beta into capital RE, that divided by IB, that divided by IB. IB and IB will cancel. What remains? Beta RE plus 1 plus beta into capital RE. Beta RE plus 1 plus beta into capital RE. Take it as equation 1. Now Zi, this is Zb, not input impedance. This is impedance at the base terminal. Impedance at the base terminal. Now if we want input impedance, input impedance is nothing but the impedance seen at the input terminals, that is between base to emitter terminals. Impedance seen between base to emitter terminals is the input impedance, that is Zi is equal to Vi divided by Ii. Voltage at the input terminals is Vi, current into the input terminals is Ii. Therefore, Vi by Ii gives the input impedance Zi. How the input impedance is obtained? Input impedance is the impedance seen from at the input terminals, that is between base to emitter terminal. This is given by input voltage, that is Vi, divided by input current. Input current is Ii. Therefore, Vi by Ii gives the input impedance Zi. Therefore, Zi is equal to Vi divided by Ii. Now, this is Zi. How to obtain this Zi? This is between base to emitter terminal Zi, that is Rb, this resistance Rb, parallel with the impedance Zb. Rb is here, whereas Zb is between base terminal to ground. Correct? Therefore, if we take the parallel combination of Rb and Zb, that gives the impedance seen at the input terminals, that is Zi. Therefore, Zi is equal to Rb parallel with Zb. Rb parallel with Zb gives Zi. It is written here. Zi is equal to Vi by Ii. That is Rb parallel Zb. That is, take it as equation 2. Rb parallel Zb. Take it as equation second. Now 1 plus beta is approximately beta, because beta is larger than 1. Therefore, this can be approximately taken as equal to beta. If we substitute 1 plus beta is approximately equal to beta, equation 1 will become, in equation 1 plus beta, this is nothing but beta. Therefore, beta into small re plus beta into capital R. That will be our equation. That is, Zb is equal to beta into Re plus beta into Re. Okay, here 1 plus beta is beta. Therefore, that is Zb is equal to beta Re plus beta into capital R. Take beta common. We will have beta multiplied by Re plus capital Re. Beta multiplied by Re plus capital Re. That is, Zb is equal to beta into Re plus capital Re. But what about Re plus capital Re? Which is larger among these two? The small Re is larger or capital Re is larger? Which is larger among these two? Yes. Small Re is larger or capital Re is larger? Which is larger among these two?
Capital R, sir.
Capital Re is larger. Very good. So capital Re is larger because small Re is 26 millivolts by I. It is smaller value. Okay. Capital Re, it is larger as compared to Re. Therefore, Re plus Re can be written as approximately equal to capital Re. Re plus Re can be written as approximately equal to capital Re. Therefore, this Zb equation will become Zb is approximately equal to Re plus Re can be written as capital Re. Therefore, Zb is approximately equal to beta into capital Re. Beta into capital Re. Take it as equation 4. We derived the equation for input impedance and then the equation of the impedance at the base terminal, that is beta into Re. Now let us find the equation for output impedance. Output impedance Z0. You all understood here how to find the equation for the input impedance? Everybody understood here? Yes. Everyone understood here how to find the equation for the input impedance? Clear here? Yes. Abhay? Abhay, is it clear? Abhay? Adarsh? Adarsh? Harshigowda? Harshigowda?
Yes, sir. Understood, sir.
Understood. Okay, fine. Let us move on to output impedance. So if you want to find the output impedance, then we have to express the circuit in the form of a KVL. Okay, we have to express the input voltage, output voltage in the form of a KVL so that we can get the equation for the output impedance and then the gain equation and the current equation. Okay, for that what we are doing, Zb, whatever we have found out, that is Vi by Ib, we have to express Zb as Vi by Ib, right? Zb is given by, Zb is the impedance at base terminal, it is the input voltage divided by the base current Ib. Okay, Vi at the terminal, base terminal, and the current at the base terminal is IB. So VI by IB gives the impedance at the base terminal. ZB is VI divided by IB, or IB is VI by ZB. Just rearrange the terms. IB will be equal to VI divided by ZB. VI divided by ZB. IE is 1 plus beta into IB. IE is 1 plus beta into IB. Therefore, IB, rearrange the terms here for IB. IB will be equal to IE divided by 1 plus beta. IB is equal to IE divided by 1 plus beta. Therefore, we have IB. What is the main equation for IB here? IB is VI by ZB. We got here VI by ZB. Right? IB is also equal to IE divided by 1 plus beta. Therefore, IE divided by 1 plus beta is equal to VI divided by ZB. What equation we have got here? IB is equal to VI by ZB. Therefore, VI by ZB, IB is also equal to IE by 1 plus beta. IE divided by 1 plus beta, that is equal to VI divided by ZB. Therefore, what is IE? IE is equal to 1 plus beta into VI divided by ZB. Cross multiply. IE will be equal to 1 plus beta into VI divided by ZB. Following here. Now, we got the equation for IE. Substitute for ZB from equation 1. What is the equation 1 we have for ZB? ZB is equal to beta into RE plus 1 plus beta into capital RE. ZB is beta RE plus 1 plus beta into capital RE. Substitute that here. Therefore, IE is equal to 1 plus beta into VI divided by ZB is beta RE plus 1 plus beta into capital RE. Beta RE plus 1 plus beta into capital RE. 1 plus beta is approximately equal to beta. Agree with me? 1 plus beta is approximately equal to beta because beta is larger than 1. Beta is larger than 1. Therefore, 1 plus beta is approximately equal to beta. So, wherever it is 1 plus beta, replace it by beta. Therefore, what we get here? IE is equal to beta VI divided by beta RE plus beta into capital RE. I is equal to beta Vi divided by beta Re plus beta into capital Re. That is our next equation. Therefore, beta Re plus 1 plus beta Re, that is approximately equal to beta Re plus beta capital Re. Beta is common. Therefore, that will be beta into Re plus Re. Beta into Re plus Re. So, using these relations, we have I is, what is I? It is simply beta into Vi. 1 plus beta is beta. Beta into Vi divided by beta is common in the denominator. Re plus capital Re. That is the next equation. I is equal to beta Vi divided by beta into Re plus capital Re. Beta and beta will cancel. Yes, beta and beta will cancel. Therefore, we have Vi is equal to I into Re plus capital Re. Vi is equal to I into Re plus capital Re, or Vi is equal to I Re plus I into capital Re. That is, we express the input voltage in the form of the KVL equation. So, to express the equation in the form of input voltage, output voltage in the KVL equation, we are first taking the equation for the, that is ZV equation, right? Then we are getting the equation in the form of base current. Okay. Then we are getting the expression for the emitter current. Emitter current. So once we get the equation for emitter current, we are expressing the input voltage. First ZB, then base current, then emitter current. Emitter current. Then we are writing the equation for the input voltage in terms of IE and the output voltage IE into capital R. Because what is IE into capital RE? IE into capital RE, just look into the circuit. IE into capital RE is V0. IE into capital RE is V0, output voltage, right? Therefore, here we have equation Vi is equal to IE into small re plus V0. IE into small re plus V0. Now, equation 6 is the KVL equation, and it can be represented in the form of a circuit as shown in the next figure. IE into capital R is the output voltage V0. I into capital R is the output voltage V0. Okay. Therefore, we have Vi. This is Vi here, input voltage. Vi is equal to IE into small re plus IE into capital Re. Okay, both are in series. So one is small re, IE into Re plus IE into capital R. Okay. That is, it can be expressed in the form of a KVL equation. Vi is equal to IE into small re plus IE into capital R. Where I into capital R is our V0. Therefore, V0 is shown here. I into capital R is V0. Then output impedance is Z0, seen from the output terminals. Input impedance is the impedance seen from the input terminals. Output impedance is the impedance seen from the output terminals. Okay. So this is the circuit that we get from the KVL equation. VI is equal to IE plus I into capital RE. Now we have to find Z naught. If we want to find Z naught, we have to make the active elements 0. Which are the active elements here? Active element is the one which is generating the energy, that is the input voltage here. Correct? Input voltage, energy supply. Okay, it is providing, it is an active source. Correct? Active device, because it is supplying the voltage. Right? We have to make this supply voltage 0 if we want to find the output impedance. Right? If we are finding the impedance at the output terminals, we have to make this input voltage 0. Otherwise, what will happen? Performance parameters will be affected because of the input voltage source. Right? Because of this, what we are doing is we are short circuiting this input voltage. We are making it 0 so that we will be able to obtain the output impedance. So whenever we are finding the output impedance, we have to short circuit, we have to make the active devices 0, we have to off the active devices. Clear here? We have to off the active devices so that we will be able to find the value of the output impedance. We have to short circuit. If it is a current source, then we have to open circuit. If it is a voltage source here, we have to short circuit the voltage source according to our rules, right? So that we will be able to find the value of the output impedance. To find Z naught, let us set Vi to 0. The resulting circuit will be as shown here. If we short circuit Vi to 0, then the resulting circuit will be Re in series with capital Re, small re in series with capital Re. Okay. Here there is a node here, so it is not series. Actually, it is parallel combination of Re and capital R because there is a node output voltage here. Okay. So let us find Z naught. To set Vi to 0. Set Vi to 0. The resulting circuit is as shown below. Re, then we have Re at the output terminal. Okay, there is a output voltage V0 across capital Re, and the output impedance is Z0. Are you following here, students? Yes. Mahadev, are you following here? Mahadev? What here?
Sir.
Mahadev?
Yes, sir.
You are following here, Mahadev? Mahadev?
Yes, sir.
Okay, fine. Now here we have Re. There is a node here, output node here at this junction. So Z0 is given by Re parallel Re. That is small Re parallel with capital Re. That is our output impedance. Okay, if it was a current source here, it was open circuited, then the output impedance would have been only capital Re. But here it is a short circuit because it's a voltage source. According to our rules, we are short circuiting. Then Re will be, small Re will be in parallel with capital Re. Therefore, we have Z0 is equal to small Re parallel with capital Re. Small Re parallel with capital R, that is Re into Re divided by Re plus Re. Now Re plus Re, it can be approximately equal to capital Re because capital Re is more than small Re. Therefore Re plus Re, it is approximately equal to capital Re. We get Z0 is equal to Re into capital Re divided by capital Re. Capital Re and capital Re will get cancelled. We get Z0 is equal to only small Re, that is emitter resistance. Therefore, the value of output impedance for the emitter follower configuration is emitter resistance, that is small Re. Okay. So we found out the equation for the output impedance. Next, let us find out the equation for voltage gain. We know that voltage gain is given by the ratio of output voltage to input voltage. Voltage gain is ratio of output voltage to input voltage. Here we are applying voltage diversion rule to the circuit, to this circuit. Okay, to the circuit whatever we are having, the KVL circuit, to this circuit, if we apply voltage divider rule, then we will be able to find the value of output voltage. Correct? According to the voltage divider rule, what does voltage divider rule state? What is voltage divider rule? Who will tell me what is voltage divider rule? Prajwal Gowda. Prajwal Gowda. What is voltage divider rule? Prajwal Gowda.
Sir.
Yes, please. What is the voltage divider rule?
So resistance of so voltage divider rule is so current into resistance of other circuit divided by total resistance.
No, that is current divider rule you are telling. Voltage divider rule I am asking. Voltage divider rule. Current divider rule is that is what you are telling. Okay. Voltage divider rule is main voltage. Now, if we want the voltage at this particular resistance across this resistance, correct? So, voltage across this particular resistance is main voltage, that is VI, into resistance of the same branch divided by sum of the resistances. Am I right? So, voltage across capital RE, that is given by main voltage VI into resistance of the same branch, that is capital RE, divided by sum of the resistances of the two branches, that is small re plus capital RE. Remember, voltage divider rule is main voltage into resistance of the same branch divided by sum of the resistances of the two branches. Okay, so accordingly we can write V0 equal to main voltage is VI into resistance of the same branch, that is capital RE divided by sum of the resistance, that is RE plus capital RE, small re plus capital RE. AV voltage gain is output voltage by input voltage. AV voltage gain is ratio of output voltage to input voltage. That is, this will be equal to, so I will take this VI to the denominator, it will become V0 by VI, that is equal to capital RE divided by small re plus capital R. AV is equal to V0 by VI, that is equal to capital RE divided by small re plus capital RE. Take it as equation 9. Equation 9. Now, accordingly, just as we have discussed, capital RE is very, very larger than small re. Therefore, RE plus RE can be, RE plus capital RE can be replaced as simply capital RE. RE plus capital RE plus small re can be replaced as simply capital RE. That is, AV is equal to V0 by VI. That is approximately equal to capital RE divided by capital RE, because capital RE plus small re is capital RE. RE and RE will cancel. Therefore, we get that is equal to 1, approximately equal to 1. That is, output voltage is approximately equal to input voltage. Input voltage. Okay, note that it is approximately equal, not exactly equal. Therefore, accordingly, what we can say here, output voltage is equal to input voltage approximately, or the output voltage follows the input voltage. What is the meaning of following? Following means the output voltage equals the input voltage, or output voltage is equal to input voltage, or we say that the output voltage follows the input voltage. Like this, we have found the equation for the voltage gain, which is approximately equal to 1 for the emitter follower configuration. Clear here? Next, let us find out the equation for the current gain. Current gain. Now, if we want the equation for the current gain, first we have to write the equation for output current, input current. Take the ratio of these two currents, output to input current. Okay. Now, the equation for the output voltage V0, we know that it is I into capital R. Okay. Here, if we'll see here in this circuit, RE equivalent circuit, V0 is given by IE into capital RE. V0 output voltage is IE into capital RE. But IE is equal to minus I0. Why? Because IE and I0 are opposite to each other. Emitter current and output current are opposite to each other. Therefore, IE is minus I0. IE is minus I0 because both are in opposite directions. Therefore, we have V0 is equal to IE into RE. V0 is equal to IE into RE, but IE is minus I0. Therefore, minus I0 into RE, because IE is equal to minus I0. That is, IE and I0 are opposite to each other. They are opposite in direction with respect to each other. Okay. Therefore, I0 will be equal to minus V0 by RE. I0 will be equal to minus V0 divided by RE. That is, I0 current is equal to minus V0 divided by emitter resistance, that is resistance connected to the emitter term, capital RE. Okay. What is II? II, we know that it is input voltage by input impedance. Yes or no? II, it is nothing but input voltage divided by input impedance. II, this current This current II is input voltage VI divided by input impedance ZI. VI divided by ZI, that gives the input current II. Write it. II is equal to VI by ZI. II is equal to VI by ZI. Therefore, current gain is output current by input current. I naught is minus V naught by RE. II is input current is VI by ZI. Divide them. I naught is minus V naught by RE. This divided by input current is VI by ZI. This divided by VI by ZI. That will be minus V naught. This division will become cross multiplication. Denominator ZI will come to numerator. Numerator VI will come to the denominator. Therefore, we have current gain is equal to minus V naught divided by VI into ZI divided by RE. VI will come to the denominator, ZI will come to the numerator. It is cross multiplication. Division will become multiplication. Therefore, we have minus V naught by VI into ZI divided by RE. What is V naught by VI? It is gain. Just we discussed voltage gain. It is V naught by VI. V naught by VI is AV, voltage gain. Correct? Therefore, this will be equal to minus AV into ZI divided by RE. Minus AV into ZI divided by RE. V naught by VI is AV. That is minus AV into ZI divided by capital RE. Take it as equation 11. This is the equation for the current gain. Current gain equation for the emitter follower circuit is minus AV ZI divided by RE. Okay. Memorize these formulas. They will be helpful when solving the derivation and also when solving the numericals. Okay. Now, what about the phase relationship? If we look into the equation for the gain, that is here, V naught is approximately equal to VI. This equation, V naught is approximately equal to VI. Output voltage follows the input voltage, and also output voltage is plus VI. Okay, it is plus VI. Output voltage is plus VI. It indicates that the output voltage and input voltage are in phase with each other. Output voltage and input voltage are in phase with each other because output voltage is equal to plus VI. Therefore, we say that the phase relationship, positive sign for AV in equation 10 indicates that V naught and VI are in phase with respect to each other. This is the phase relationship, right? Is it clear here, students? Performance parameters of emitter follower configuration. Understood here? Rutik Chopde, is it clear here? Rutik? Understood here? Rutik Chopde? Rutvik Gune? Rutvik?
Yes, sir.
Understood,
Yes, sir.
Rutvik? Okay.
Yes, sir.
Fine, fine. Sagar, is it clear here? Sagar? Sai Prakash? Sai Prakash?
Yes, sir.
Understood here? Performance
Yes,
parameter
sir.
derivation? Huh?
Yes, sir.
Okay, fine. Let us solve an example here. Take this example quickly. For the emitter follower shown below, calculate small re, b, zi and z0, c, av and ai. Take beta equal to 100 and r0 equal to infinity. The circuit is given. For the emitter follower shown below, calculate A, emitter resistance RE, B, input impedance ZI and output impedance Z0, C, AV voltage gain and AI current gain, beta, that is current gain is 100 and R0 output resistance is infinity. Note down the circuit quickly. This is the emitter follower circuit where the input voltage is applied to the base terminal. Note that output voltage is taken from the emitter terminal in the emitter follower circuit. Like this, we can identify that it is an emitter follower circuit by looking into the circuit. Sometimes they may just give for the circuit shown below, calculate RE, ZI and Z0, AV and AI, take beta equal to 100, R not equal to infinity. So if you give like that, if they give like that, then you have to first identify which circuit is this. The circuit is the emitter follower circuit because the input voltage is applied to base terminal, output voltage is taken from the emitter terminal. You have to identify and then you have to start applying the required formulas. Clear here? And sometimes what they may give in examination for the emitter follower for circuit, calculate RE, ZI, Z0, AV, AI, take beta equal to 100, R0 equal to infinity, RB equal to 220 kilo ohm, RE equal to 3.3 kilo ohm, VCC equal to 12 volts. They may give in the form of a statement. Okay. So if they give in the form of a statement, first you have to draw the circuit, write the given data, apply the required equations and then calculate the value of the unknown parameters, required parameters. Clear here? So this is how we have to approach in solving the numericals. Note down the circuit here. Note down the circuit. Coupling capacitor is input coupling capacitor is 4.7 microfarad, input current II, input voltage VI, then RB base resistance, it is 220 kilo ohm. Okay, there is no collector resistance is not there in the emitter follower circuit. VCC plus 12 volts. Emitter resistance, the resistance connected to emitter terminal, it is capital RE. Okay, it is capital RE, it is 3.3 kilo ohm. Then output capacitor, that is capacitor connected to the emitter terminal, it is 4.7 microfarad. Note that there is difference between small RE and capital RE. Small RE is emitter resistance by replacing the diode circuit. Okay, that is RE is equal to 26 millivolt by IE. Small RE is 26 millivolt by emitter current IE. Okay, whereas this is capital RE, it is 3.3 kilo connected to ground here. Okay, please note the difference between the two. And output impedance is Z0. Output impedance is Z0. Input impedance is ZI. Okay. Noted down this circuit, students. Noted down here.
Now, there should be in the entire sector with your response, there should be in guidance less than
Sanya, did you all note down the circuit? Sanya? Sanya, did you note down the circuit? Sankalp, did you note down the circuit? Sankalp? Circuit is noted down. Sanket?
Yes, sir.
Noted down the circuit.
Writing, sir.
Shiraj? Shiraj?
Doing so.
No, not the solving of example. Noted down the circuit diagram.
Yes, sir.
Note it down. Okay, right. Okay. See here. First, what they have asked? They have asked the value of small RE. We know that small RE is given by emitter resistance is 26 millivolt by IE. Okay, first you have to know this formula, main formula. Okay, main formula is RE is equal to 26 millivolt by I. So if you want to calculate this small RE, we should know capital I, emitter current. Okay, so equation for emitter current is 1 plus beta into IB. We know the equation for this emitter current, that is 1 plus beta into IB. Beta is given. They are given the value of beta is 100. Correct. Now we don't know IB. Base current we don't know. Therefore, we have to find the value of IB first. Correct. Now, how to find the value of IB? See here in this circuit diagram. In this circuit diagram of the emitter follower, apply the KVL to the input path. Apply the KVL, that is from VCC through base resistance RV, VB, then emitter resistance RE to ground. Apply the KVL to the input section, to the input part of the emitter follower circuit. If you apply the KVL equation, then what we get here, students? If you are applying the KVL, if you are applying the KVL here, what we get? Just look here. Now VCC starts from the VCC. VCC is equal to VCC equal to or minus IBRB minus IBRB. Okay, minus VBE minus VBE. Okay, minus VBE, right? Then minus IERE minus IERE. Okay, this is equal to 0. Am I right here? See the circuit. See the circuit here. VCC VCC minus IBRB, apply KVL to the input part of the input section of the circuit. VCC minus IBRB minus VBE, current entering is positive, current leaving is negative. VCC minus IBRB minus VBE minus IERE is equal to 0. Correct? VCC minus IBRB minus VBE minus IER is equal to 0. Accordingly, what we get here, we want the equation for which one? We want the equation for, let us see the circuit equation. So we want the equation for IB. So if you want the equation for IB, right, we have to express the emitter current in the form of base current. I is given by 1 plus beta or beta plus 1 plus beta, 1 plus beta into IB, 1 plus beta into IB. Now substitute this I is equal to 1 plus beta into IB in above equation, this equation 1. Okay, in this equation 1. Okay, if we substitute I is equal to 1 plus beta IB in above equation 1, we get, write it, VCC minus IBRB okay, minus VBE minus 1 plus beta minus 1 plus beta into 1 plus beta into IB into RE, this is equal to 0. Correct? I am substituting I is equal to 1 plus beta IB into RE is equal to 0. Now I want the equation for IB. Okay, so VCC minus VBE, rearrange the terms, minus IB, I will take common, minus IB, okay, that into, so in this I minus IBRB, then minus 1 plus, minus of 1 plus beta IBRE, IB is common, take it outside, RB plus 1 plus beta into RE, okay, this is equal to 0, sorry. Therefore, what we get here, VCC minus VBE is equal to IB into RB plus 1 plus beta, RB plus 1 plus beta, right, 1 plus beta into RE, okay. Therefore, IB is equal to VCC minus VBE, right, VCC minus VBE this divided by RB plus 1 plus beta into RE, okay. So this is the equation for the base current IB, VCC minus VB divided by RB plus 1 plus beta into RE. This equation I have written here. IB is equal to VCC minus VB divided by RB plus 1 plus beta into RE. Okay, so you have to apply the KVL to the input section, so that, and express the emitter current in the form of base current I is equal to 1 plus beta into IB. Then after rearranging the terms, simplifying, we'll get the equation for IB as VCC minus VB divided by RB plus 1 plus beta into RE. Now we all know all these terms. VCC is 12 volts, VB is 0.7, RB they have given 220 kilo ohm. Just look into a circuit. RB base resistance is 220 kilo ohm plus 1 plus 100, beta is 100 into RE, emitter resistance, that is capital RE, 3.3 kilo ohms. That will come out to, if you simplify this, just find out this, take it for homework, 20.42 microamperes. Okay, 20.42 microamperes. Just solve this and compare your answers. 20.42 microampere you should get. Okay. Then IE is equal to 1 plus beta into IB. IE is equal to 1 plus beta into IB. 1 plus beta into IB, right? That is 1 plus beta is 100. They have given this into 20.42 microampere. 20.42 microampere. If we solve this, so 101 multiplied by 20.42 microampere will get 2.062 milliampere. Okay, 2.062 milliampere. We found the value of IE. Now we can substitute in the equation for RE, small RE, that is 26 millivolt by IE. We will get 26 millivolt divided by this current 2.062 milliampere, whatever we have calculated. That will be 12.61 ohms. The value of small RE emitter resistance is 12.61 ohms. Okay, we found the value of small RE. Next, what they have asked? They have asked ZI and Z0, input impedance and output impedance. First, let us find the value of ZB, because we know the equation for ZI input impedance as RB parallel ZB. Correct? ZI input impedance is RB, that is this resistance RB. We look into this circuit here. This resistance RB, right, parallel with ZB. ZB is looking from base terminal to ground, impedance between base terminal to ground. Therefore, RB parallel ZB will give the input impedance ZI between the input terminals, base and emitter. Therefore, ZI is equal to RB parallel ZB. Okay, so if we want ZB, then we have to write the equation for ZB. We know the equation for ZB. It is beta RE plus 1 plus beta into RE. Let us go back and check this equation where we came across equation for ZB. So ZB is here, equation 1, the very first equation when we are finding the input impedance. ZB is equal to beta RE plus 1 plus beta into capital RE. ZB is equal to beta RE plus 1 plus beta into capital RE. Okay, take the main equation. ZB is equal to beta RE plus 1 plus beta into capital RE. We know the equation for ZB now. We know the equation for ZB, right? Beta RE plus 1 plus beta into capital RE. Beta is 100 into small r is 12.61 plus 1 plus beta is 1 plus 100. This into capital R, that is 3.3K. RE resistance here, 3.3K. If we simplify this, then we should get 334.56 kilo ohms. Just compare your answers. We'll discuss again. Okay, 334.56 kilo ohms. Then ZI is equal to RB parallel ZB, that is 220 kilo ohm parallel with 334.56 kilo ohms. RB, it is given 220 kilo ohms RB resistance parallel with ZB. ZB is just now we have calculated, that is 334.56 kilo ohms. If we take the parallel combination of these two, that is 220 kilo ohm parallel with 334.56 kilo ohm. How to find the parallel combination? 220K into 334.56 kilo ohm, the whole divided by 220 kilo ohm plus 334.56 kilo ohms. If we simplify that, then we'll get 132.72 kilo ohms. That is the input impedance. Then output impedance Z0, that is capital RE parallel small RE, where we came across this equation. Here Z0 is here, RE parallel capital RE, Z0. We made Vi 0. After making Vi 0, we got Z0 as small RE parallel capital RE, small RE parallel capital RE, right? That is Z0 is main equation, RE parallel capital RE, that is small R into capital RE, that divided by small RE plus capital RE. Take that equation. Z0 is small RE parallel capital RE. Capital RE is 3.3 kilo ohms. 3.3 kilo ohms parallel with small R is 12.61 ohms. We have calculated in the part A. Small r 12.61 ohms. If we take the parallel combination of these two, we get 12.56 ohms. 12.56 ohms. That is the output impedance Z0. Clear here? Now what is left? Last part, voltage gain and current gain. Did you follow here, students, how we are getting this IB? There is RE and ZI and Z0. Part A and part B all understood here? Part A and part B? Yes? Part A and part B all understood here, students? Shubham? Part A and part B of the problem you all understood? Shubham? Yes, please. Suraya Banu? Suraya Banu?
Yes, sir.
Part
Understood,
A and
sir.
part B, you all understood here?
Yes, sir.
Suraya Banu?
Yes, sir.
Okay, fine.
Understood.
Okay. Next is part C. We have asked voltage gain and current gain. Voltage gain and current gain. Equation for voltage gain is AV is equal to capital R divided by capital RE plus small re. Right? AV is equal to written equation for AV. Where is the equation for AV? We have written here. Main equation AV is equal to capital RE divided by small re plus capital R. AV is equal to capital R divided by small re plus capital RE. Okay, this is the equation for the voltage gain. Main equation you have to take, not the one simplified one. If you are taking the simplified one, you will get V naught is equal to Vi, that is AV is equal to 1, you will get, not this equation. Main equation we have to take. Okay, we have to calculate the actual value of the voltage gain and the current gain. So take the main equations always. Taking the main equation, AV is equal to capital R divided by capital RE plus small re. Capital R is 3.3K divided by 3.3K plus 12.61 ohms. Small r is 12.61 ohms. That comes out to 0.996. 0.996. Next, calculate the current gain AI, that is minus AV ZI divided by RE. Just now we have calculated the AI equation. Current gain AI is minus AV into ZI divided by capital RE. Current gain AI is equal to minus AV into ZI divided by capital RE. Okay. Is AV is equal to minus AV ZI divided by capital RE. Substitute AV is 0.996 into ZI is 132.72 kilo ohms. We have calculated that ZI is here. ZI is 132.72 kilo ohms divided by RE, emitter resistance, capital RE, 3.3 kilo ohms. If we simplify this, answer is minus 40. Minus 40. Okay, that means current gain is negative here. What it indicates? Current gain negative. Output current by input current is current gain. Output current and input current are out of phase with respect to each other. That is the meaning of negative current gain. If voltage gain is negative, it indicates that output voltage and input voltage are out of phase. If current gain is negative, then it indicates that output current and input current are out of phase with respect to each other. Clear, yes, students? Just noted down these values. IB will get 20.42 microampere. Just note down. IE is 2.062 milliampere. Then RE 12.61 ohms. ZB 334.56 kilo ohms. ZI 132.72 kilo ohms. Z0 12.56 ohms. Okay. Just note down this quickly.
And then in the denominator, Z1 is 1. So only one side of that 4 is also 1 4 is 1. That is add Z1 is 0, Z is equal to 1. 1 4 is like alpha.
Note down only the main formulas. Calculation you will do and verify your answers. Right? Then here AV 0.996, AI will get minus 40. Note it down here, students. Right? And here, any doubts here, students? Any questions? Students? Prathamesh, any questions? Prathamesh Patil? Shubham, any questions?
No, sir.
Okay. Understood here, Shubham?
Yes, sir.
Any problem in understanding?
No, sir.
Okay. Kirti, is it understood? Kirti? Kirti? Janvi, is it understood? Janvi? Janvi? Abhay, is it understood? Abhay?
Yes, sir. Yes, sir.
Clear with the topics, today's topics, Abhay?
Yes, sir.
Okay. Then we'll continue in the next class. Next class I will be taking, that is emitter follower, considering the voltage divider bias. Emitter follower considering the voltage divider bias. Then we'll solve example. Emitter follower using collector resistance, right? Then we'll solve examples on that. Okay, that will take up in the next class. Thank you.
Also, only